Good morning, my name's Ian Crook. I'm from ISA Software in Paris. I'll just wait for the slide to come up. I'm going to present to you the ORCI project, which is a TRL2 exploratory research project carried out by 4 partners. And the partners involved are INAIRI, who are an ANSP in Spain, Barcelona, NAV Portugal, an ANSP in Portugal, INECO, a tech firm in Madrid, and ourselves, ISA Software in Paris. ORCI is basically an AI tool which optimizes the runway line interception, and all it does is very simple. It gives recommendations to the air traffic controller. If I instruct this aircraft to turn now, this will be the separation at a given point, and that separation is the choice of the air traffic controller themselves. So if they want 5 miles at that point, they turn on 5. If they want 8, they turn on 8, etc. It supports runway operations in multiple modes, segregated and mixed modes, and we've tested it on trombone systems at Barcelona and the point merge system at the Lisbon airbase. ORCI remains an advisory tool, that's very important. The ATCO is not taken out of the loop, the ATCO is not replaced, the ATCO is simply supported. There's no change to any of the separation minima, there's no change to the regulatory framework, and as I said previously, they can work to any desired target separation, which changes according to the conditions of the airport, if it's bad weather, low vis, etc., etc. The technology and the solution is very simple. It's a machine learning-based predictive model which continuously provides spacing predictions throughout the arrival process for pairs of aircraft, and once done, it immediately moves to the next pair. The ML itself accounts for all of the different aspects that are involved in the giving of the instructions, which includes the ATC phraseology, the pilot response times, aircraft turn dynamics. We have a very, very high precision simulator that we used, wind and compression effects, and the refresh rates, etc. The overall objectives of our thing was to improve the interception timing precision, which in turn increases the arrival throughput without reducing any of the existing separation minima. We get rid of the excess spacing buffer, which is typical in this type of operation. We reduce unnecessary vectoring and subsequent fine-tuning operations, such as speed modifications during final approach, additional vectoring during the turns, etc. And therefore, we intend to improve human performance and specifically the resilience during the peak hour. All of this contributes to both capacity, efficiency, safety, and cost KPIs. We did the simulation using a cloud-enabled distributed simulation platform. None of the partners ever went to any of the partners' sites. We did all of this remotely, all of the training, all of the execution. The simulation ran in Paris. The ORCI AI was working as an on-demand service in Madrid, and the simulations were carried out at the ACC in Barcelona and at the ACC in Lisbon. So just going to the focus that we have for this particular conference, we're looking at the operator experience, in particular from the ANSP's perspective, because that's the people we're working with and working for. In that sense, we've increased the efficiency. We can show increases in efficiency of the TMA throughput, especially during the very, very high level or very challenging situations. We're able to optimize the spacing buffer, reducing that excess margin. We can achieve much higher, I will qualify that later, higher peak arrival handling capacities, especially in the Barcelona case, where they were using segregated mode. And we have much fewer merging issues under the very high complexity situations. We also noticed there was a lot of reduced communication and a potential increase of the number of flights that are handled by the ATCO every hour. Quite a significant increase in principle. In practice, our scenarios were 30 to 45 minutes long when we ran with the ATCO in a real-time hybrid simulation. In reality, if you multiply that by the number of times you have these situations per year, it can work out to be a very, very large gain in terms of throughput without modifying any capacity at those airports. From the ATCO perspective, the human operator, they're able to achieve a better real-time predicted spacing at the interception points, a much reduced cognitive burden, especially when they're estimating the uncertainties of implementing these turns, when to instruct the turn and monitoring those turns. A much lower need for any corrective actions, improved situational awareness and workload distribution throughout the whole scenario, and an increased confidence in both the timing of those decisions, whilst maintaining the full authority for the control, so they can adapt to any different types of conditional needs according to what is happening at the airport at that particular day. So from the operator experience, we're shifting from this operator using their own expertise and experience to mentally manage the uncertainty of these aircraft when they turn, how they arrive at the far side of that turn, and then therefore the refinement of those positions and the final approach, homogeneity, to a supported decision-making process in which they can achieve homogeneity from the start. This in turn, of course, has knock-on effects to the airport operator, because that airport operator will achieve a better peak runway throughput in both segregated and mixed modes, because there is a more consistent arrival spacing. The runway slot predictability is much improved, and there's better gap management, allowing departure integration during the mixed mode operations that we simulated in the single runway operations at Lisbon. We also noticed that there's a reduced arrival variability at the threshold, and we have a lot better stability during the traffic peak periods, where the air traffic controllers need to work a lot less to achieve a lot more actual traffic throughput. So in that sense, they're going from that reactive experience and their own expertise to manage the gaps at the runway to a much more predictable and a very much more homogeneous arrival stream, as we'll see in a second. Of course, from the airline operator perspective, this also has a natural knock-on effect, because they're doing fewer vectors, they're not flying as far on the outbound legs and on the turns, they're reducing the miles that they fly within the terminal area, and as a consequence, if they're flying less miles, they're also using less fuel, they're burning less CO2, they're making less SO2, NOx, etc. And the arrival times are more stable and more predictable. And they're having to do less work on the flight deck because they're not correcting themselves subsequently through additional vectoring controls or additional speed controls, which are carried out to manage the traffic on final to line it up. So from the airline perspective, we're going from these tactically overstretched paths sometimes to a much more optimized and consistent sequencing methodology in both tromboning and in the point merge system. We looked specifically at the human performance perspective. The results we're showing here are very high level at the moment because we only finished the validations on Friday. So I pulled together just a few of these statistics. But overall, we were seeing that from the workload perspective, the air traffic controllers are showing a significant reduction in both mental, physical, and overall workload. So you can see on the first top right graph, it's dropping to almost 50%. These are qualitative assessments because we're only a TRL2 level, but they're done through questionnaires using the Likert scale, which are done straight away after the simulations by the ATCO who were concerned. And we ran ATCO simulations for both Barcelona for 2 weeks and subsequently Lisbon for another 2 weeks. So we've had 4 weeks of simulations with active controllers who finish their shift, come on, do the simulations at the ACC, answer the questionnaires, then go home. So it's at the end of their shift. Similarly, from the situational awareness, the graph is the opposite way around. We can see that without the ORCI tool in place, the utility of the information that they had is obviously okay, because they're used to what they see on their HMI, they're used to their controller working position, they have all of the different tools that they have associated, they have an armband, they have a distance linkage, etc. But once the ORCI tool was there with its extra information, just a simple spacing predictor, they found a slightly higher utility. They had an improved understanding. Obviously, there isn't an improvement on the understanding without ORCI because it's what they do every day, so we haven't put any value in that one. And overall, they found that they raised, on average, from a level 3 on the Likert scale to a level 4.5 on average across the entire series of simulations that we carried out. Finally, we asked them about what they thought about the tool itself, the trustworthiness, the reliability, the predictability if the predictions were close to what they were actually achieving at the far side of a turn. And all of them came extraordinarily high, between 4 and 5. Reliability high, accuracy similar, understanding behavior they understood within, I would say, a matter of about 3 minutes of using the tool. They had a full understanding of what it was doing, why it was doing it, what it was helping them with, and they were fully confident in using it. And at the end of the runs, we even got comments saying, like, I'm a bit upset by this because I enjoy my job and I'd like to continue doing my job, and this may replace me eventually. It won't, of course, but these are the kind of sentiments that we felt that we got at the end. The mechanism itself was, as I say, to improve the separation management at the interception point. So the interception point is not the runway threshold, it's the point that the intercept, the extended final, the red line that you see on the top, or the interception point is the merge point on the point merge at the center of the kind of triangular arc, the point PESEX in Lisbon, where they join the final approach. That is predicted continuously. So as you can see on the top screen there, you can see that the pair of aircraft which are being predicted are in blue. The aircraft which is lead has no prediction, it's already got its prediction stored from the previous pairing, and the second one has got a continuous update. Currently it's reading minus 0.42 nautical miles, which means that if the ATCO instructed this aircraft right now, it would be 0.42 miles in front of the other aircraft, which we don't want, obviously, yeah? And that continuously updates every second as it repredicts until such a point that they want to make the turn. They make the instruction, they get the response from the pilot inputs the information into the FMS, the aircraft starts slowly to turn and eventually makes the turn across. Similarly with the point merge, here we're doing mixed mode operations, so we need much bigger spacing on the arrival stream because you want a departure in between each of the arrivals. So we're talking about probably an 8 miles separation at PESEX. And again, the ORCI prediction is giving them a constant, updated every second prediction of what the spacing will be if they started now. And we monitor it and measure it at the arrival point and at the runway threshold to prove that we're actually achieving that. So the KPIs we impacted were capacity, TMA throughput, peak arrival throughput, peak runway capacity throughput. We haven't got the numbers for these yet because, as I say, we only finished on Friday. But I got a few numbers from my colleagues back in Paris. And for Barcelona, for an example, the declared capacity of Barcelona using runway 02 for arrivals is 32 arrivals per hour. Using the simulation, we gave them an initial demand of around 48, so 150% of the normal capacity, very high capacity. We had quite complex traffic with aircraft coming in together, labels on top of each other, etc., etc. We told them that they were not allowed to use holding, so we made them manage the traffic as is, and they achieved a value of between 43 and 44 flights per hour with the ORCI tool in place, and only 40 without it. So we were getting about 3 flights per hour more at the Barcelona airport. Okay, the other things we're still looking at is the operational efficiency. Now, obviously, we're still working in this, so I've not put any stats up here yet. But the KPIs we're looking for is the TMA arrival time, the average distance flown, and reductions in fuel burn, which is straightforward from the flights we do because we have the full profiles. We're also looking at safety. We're assessing the safety. We're doing a safety assessment using the Eurocontrol NMAC model for the TMA system. And we're looking at the number of merging issues, which we're going to put into the model to show that it reduces them. So with that, I'd like to thank you for the attention. I was a little bit over, got carried away with the pictures. Thank you for your attention.